Question. An airplane flies due north over Sudbury with a velocity relative to the air of 235 km per hour and with a wind velocity of 65 km per hour. The direction is NE. NE means north 45 degrees toward east. Now calculate the speed and the direction of the airplane. So here, the wind velocity is just the velocity of the air relative to the earth, and the speed and the direction of the airplane is just the velocity of the airplane relative to the earth. We use P to represent the airplane, and we use A to represent the air, and we use E to represent the earth. Then the velocity of the airplane relative to the air just equals magnitude 235 kilometers per hour. The direction is north, and the velocity of the air relative to the earth is magnitude 65 kilometers per hour, and the direction is north 45 degrees toward east. Then the velocity of the airplane relative to the earth just equals the velocity of the airplane relative to the air plus the velocity of the air relative to the earth. I use the perpendicular components of a vector method to calculate this question. So this direction is north, also positive y direction, and this direction is east, also positive x direction. Then for the velocity of the airplane relative to the air, this is 235 kilometers per hour. Direction is north. Now we know that its x component is 0 kilometers per hour. Because its direction is north, north is also positive y direction. So its x component is 0. Then the velocity of the airplane relative to the air, its y component is just 235 kilometers per hour. Now let's see this equation. The left side, this velocity's y component is also a vector. So the left side is a vector, but the right side is only a magnitude. So in strict terms, this equation is not right. But we know the vector's direction is just positive y direction. So for the sake of convenience, we just use such an expression. And the textbook also uses such an expression, so I use it just for the convenience. Now for the velocity of the air relative to the earth, this velocity is 65 kilometers per hour. Direction is north 45 degrees toward east. For this velocity, I draw the graph. So this direction is north, also positive y direction, and this direction is east, also positive x direction. This velocity is just the velocity of the air relative to the earth. And this vector is just its x component. It's the velocity of the air relative to the Earth. Its x component. And this vector is just its y component. And this angle is a right angle. And this angle is 45 degrees. Then, from the graph, we can know that its x component just equals its magnitude, the velocity of the air relative to the Earth. Its magnitude multiply cosine 45 degrees. And this equals 65 multiplied cosine 45 degrees and equals 45.96 kilometers per hour. Let's look at this equation. This guy, the left side, this is a vector, but this guy is only a magnitude. So in strict terms, this equation is not right. But we know the vector's direction is just the positive x direction. So for the sake of convenience, I just use such an expression to do the calculation. And in the textbook also use such an expression. So I use it just for the sake of convenience. Now, the velocity of the air relative to the Earth, its y component equals the magnitude of the velocity of the air relative to the Earth, the magnitude of it multiplied sine 45 degrees, and equals 65 multiplied sine 45 degrees, also equals 45.96 kilometers per hour. Then we can get the x component of the velocity of the airplane relative to the Earth. Its x component just equals the velocity of the airplane relative to the air. Its x component plus the velocity of the air relative to the Earth. This velocity is x component, and this equals 0 plus 45.96 and equals 45.96 kilometers per hour. And its y component, this one, the airplane relative to the Earth, the velocity, its y component equals the velocity of the airplane relative to the air, its y component plus the velocity of the air relative to the Earth, its y component, and this equals 235 plus 45.96 and equals 280.96 kilometers per hour. Now I draw them. This vector is just the y component of the velocity of the airplane relative to the Earth. Its y component. And this vector is just the x component of the velocity of the airplane relative to the Earth. Its x component. And this vector is just the velocity of the airplane relative to the Earth. And this is a right angle. This direction is east, and this direction is north. Then, from the graph, we know that the magnitude of the velocity of the airplane relative to the Earth just equals square root the magnitude of the x component of the velocity of the airplane relative to the Earth. Its x component, the magnitude of its x component square plus the magnitude of its y component. its y component, the magnitude of it squared, and this equals 45.96 squared plus 280.96 squared, and the square root of the, and this equals 284.69 kilometers per hour. Then this angle is theta. Then theta just equals arc tangental. The magnitude of the velocities y component over the magnitude of the velocities x component, and equals arc tangental 280.96 over 45.96, and this angle is 80.71 degrees. Now we know the velocity of the airplane relative to the Earth equals its magnitude is 284.69 kilometers per hour, and its direction is east, the 80.71 degree, or north.